In this video we'll be going over solving absolute value inequalities or evaluating them. So um, what I like to do when I first teach this is that just kind of look at all the situations. Okay, so we're going to look at the first four, and then we're going to look at the next four in the next video. So um, x can be either greater than or less than a positive number. So this is greater than 10 and this one's less than 10. Or x could be greater than a negative number or less than a negative number. So really, I'm going to evaluate the absolute value of x at each situation. So down here, I think, is the easiest to think about it. So what values of x are going to be less than negative 10? Now you might say less than or equal to negative 10. You might say negative 10, negative 11, negative 12, but the absolute value of negative 12 is actually 12, and 12 is not less than negative 10. If you think about it, there are no x's that are going to be less than 10. So we say that that's impossible. Okay. Now, on the other side, think about absolute values that are going to be greater than negative 10, or really in any negative number. Well, think about it. 10 is greater than 10. Negative 10 here, because the absolute value of negative 10 is 10, and so that's obviously greater than negative 10. And back, if you think about it, absolute values cannot be negative. All absolute values are positive. So this is our symbol that we use for all real numbers. So all x's work for this. All values work. Okay, over here, no values will work. Alright, now, if you think about this, we'll do this one first. If x is greater than 10, or greater than or equal to 10, you have numbers like 10, 11, 12, 13 that work. So things that are greater than 10. So you basically am rewriting the statement. Alright, all x is greater than 10, but we also have another set of numbers that would also work. Think about this. If I plug in negative 11 here, the absolute value of negative 11 is positive 11, and 11 is greater than 10. So all numbers less than negative 10 would also work here, less than or equal to negative 10. Now this one here, if you think about it, numbers less than or equal to 10 would work. Okay, so obviously 9, 8, 7, 6, 5, all the way. Now, you can even think about negative 1. Okay, obviously negative 1 is less than negative 10, but the absolute value of negative 1 is also less than 10. So if you think about it on a number line, I started at 10, and I included 10, so I use a solid line, and I'm going, and I pass 0. Okay, everything between 10 and 0 worked, and it's continuing to work. Where it's going to stop working is at negative 10. Think about it. The absolute value of negative 10, 10, and 10 is less than or equal to 10. But after that, my answer stopped, because if you try negative 15, the absolute value of negative 15 is 15. 15 is not less than 10. So this is in between these two. Alright, so I like to show what this looks like on a number line also. Okay, so this one, x is greater than or equal to 10, that's that way. And then this is x is less than or equal to negative 10, which is the other way. So really the word in between here is or. This is an or statement, and this is an and statement. Okay, so you have to write these separate, not as a compound inequality. So why do I explore all those different situations? Well, every other type of inequality is going to follow that pattern. So I had you guys write this down and kind of make a cheat sheet out of it. If the absolute value is less than a positive, you do a small is less than x, which is less than the big number. And and so forth. So you could write these down, and if you have an absolute value that's less than a negative, that's impossible. And if you have an absolute value that's greater than a negative, that's always going to be true. The other key things is you want to make sure you get the absolute value by itself before applying, these rules above. And also, this is a big one, if you multiply or divide by a negative, you have to switch to the inequality sign. Okay, so hopefully that initial explanation helps a little bit. So here we go. So think about this. R is less than 6. All numbers less than 6 are going to work, but also all numbers less than -6 or greater than -6 would also work. Things like -10. Absolute value of -10 is 10. Oop. Oh, my bad. So greater than -10. I just tried -10 in there. Absolute value of -10 is 10. 10 is not less than 6. All right, so I just tried something that was less than -6, and it didn't work. So here we go. So this solution set, if you think about it, is open circle at 6, open circle at -6, and it's all the numbers in between. That's what that's saying. Numbers less than 6, so that's to the left of 6, and then you kind of have to read this one backwards. If you read that one backwards, R is greater than -6, which is going to the right. Alright, so it's that solution set in between. Alright, here we go. If you think about this one, N is greater than -6. All real numbers. All absolute values are going to be greater than a negative. Okay. All absolute values are positive. So keep that in mind. This one here, if R is greater than 3, okay, so all numbers greater than 3 are going to work, obviously. 4, 5, 6, and equal to 3. So that makes sense. And then if I say R is less than or equal to, what other numbers are going to work here? Well, -3 works. -4, try them. -4, absolute value of -4 is 4. 4 is greater than 3. So numbers less than -3 also work. So if I make a quick number line of this, all numbers greater than or equal to 3 and greater than or equal to -3 work. So see the difference between those two types of solution sets. Alright, number 4, x is less than a -12. That's impossible. Absolute values have to be positive, so how could it ever be less than a negative? Okay, wait. Okay, so we have the absolute value of x minus 8 is less than 1. So if you're looking on your cheat sheet, I have it up here in the corner. If you can see, it's pretty small, but if it's less than a positive, then it's going to end up looking like this. It's going to be that compound inequality. But before I do that, I need to set this and solve it. There's different ways you can do this, but since you guys are pretty good at solving, I said we'll go ahead and take the inequality and set it equal to 1 and -1 and see what you get. So if you add 8, you get x equals 9, and if you add 8 here, you get x equals 7. So you can think about this too. If you plug in 9, 9 minus 8 is 1. 1 is less than or equal to 1. Alright, so this works, and so does 7. 7 minus 8 is -1. Absolute value of -1 is 1, and 1 is less than or equal to 1. So both of these work. I've plugged them back in quick. But now how do I set up my final thing, my final answer? Well, I need numbers actually in between these two, if you think about it. So I need numbers less than 9, less than or equal to 9, but if I read this backwards, x is greater than or equal to 7. Because if you think about it, numbers greater than 9, so if you're kind of second guessing yourself, plug in 10. 10 minus 8 is 2. 2 is not less than 1. So, numbers greater than 9 do not work. So this is the only thing that makes sense. Okay, so I may get cut off here, but if I set this equal to 3 and negative 3, this is pretty quick. 5 times 3 is 15. Negative 5 times 3, or negative 3 times 5 is negative 15. So those are my two answers that I'm going to evaluate, but since it's a greater than, think about this. Numbers greater than 15 would work here, because try 20. 20 divided by 5 is 4. 4 is greater than 3. So V is greater than 15 works, but then V's less than negative 15 would also work. Try negative 20. Negative 20 divided by 5 is negative 4, but the absolute value of negative 4 is 4, and 4 is greater than 3. So those two work. This one I can do really quick because absolute values are always greater than a negative. So all reals. Okay, I wanted to get to this one because if you use your rules, you might say, hey, it's less. Absolute values are never less than a negative, but when you have to get the absolute value by itself first before you evaluate that. And two things happen here. I divided by a negative 10, so I have to switch my sign, 1, and this negative now is positive because a double negative makes positive. So now I have the absolute value of B, 4B, is greater than 12. So now I'm in situation 1, or situation 2, sorry, where the absolute value is greater than a positive. So you could almost think about this. 4 times 3 gives me something that's equal to 12. So I need something more than 3, like 4. 4 times 4 gives me 16. That's greater than 12. But if I didn't see that, I could set it equal to 12, divide by 4, and I get B equals 3. Now, I also need to evaluate this B at negative 12. Just solve the inequality. You get negative 3. Now, I shouldn't have circled those because those aren't my answer. That's just where I'm going to evaluate it. So, since it's less than, it started out less than, but now it's going to be, it's greater than. So I need numbers greater than 3. Okay, that 4 I was talking about, 5, 6, 7, 8, all those are going to make this greater than 12. But also, B's less than negative 3, like negative 4. Negative 4 times 4 is negative 16, but the absolute value of negative 16 is 16. So those numbers work. Alright, the video is kind of getting long here, so I may get cut off, but I'll try to get it in here. So I'm going to add 4 to both sides, and I notice right away I get negative 81, but when I divide by 9, 10x plus 1 is greater than negative 9. I have an absolute value that's greater than negative 9. That's always, doesn't matter what I plug in there, because it's always going to be positive. It's always going to be greater than negative 9. So right off the bat, I don't even have to evaluate that. I can just say all reals. we'll back up. I'll do 21, since we're still rolling here. Add 4 to both sides. Oops. It's less than 6. I gotta divide by 2. Okay, so our absolute value of x plus, or 8 plus x is less than 3. So I can think about what works here. Negative 5 works, because that would make 3. And then also negative 11. Negative 11 plus 8 is negative 3. The absolute value of negative 3 is 3. So you might be able to just get the answers right off the bat, but if not, you can solve that equation, and you can solve the equal to negative 3. So x equals negative 5, and x equals, I subtract 8, I get negative 11. So those are the two that I'm looking at. Now, I circled those again. Probably shouldn't have, because my answer is going to be an inequality. It's going to be between negative 5 and negative 11. Oops, wrote that backwards. Negative 11, your smaller number should go there, your bigger number should go there. So I need things less than negative 5 but greater than negative 11.